to hear each other, since we have limited numbers of microphones. Yeah. Well, this was originally scheduled to be more of a keynote-y type slot, which we had a last-minute substitution, so I'm the entertainment for the hour. But since we didn't have an ODP call this week for obvious reasons, this is effectively serving as the weekly call, the design call for ODP. So we've got another 15 seconds, so we'll wait for the buses that are delayed to get here. Okay, so it's 12:10, so we can get started. Just a commercial announcement first for those who are not already familiar with the regular interactions that we do in the ODP project. We do have a weekly call on Tuesdays at 1500 UTC, so translate that to your own time zone. If you're on the US West Coast, that's 8 a.m. So given that we have people from around the world who are participating in that, we try to pick a time that's not ridiculously early for everyone or absurdly late for others. But to participate in that, just go to uberconference.com/opendataplane and to connect to the call. You can connect through your computer, which is the preferred method, or there's also international dial-in numbers if you want to use that. And the call is open to anyone who wishes to participate. There will be no call next week, since a lot of people will be either extending their visit to the Bay Area or recovering from long-distance travel. So the next call that we will be holding via Uber Conference will be on Tuesday, September 30th. What I wanted to cover today is a number of topics that sort of came up during the course of this Connect. We had some fairly extensive discussion sessions on Monday and Tuesday afternoon relating to what we want to see in finishing up ODP 1.0, and also had some good suggestions still coming in on some of the design docs that are circulating, so I wanted to cover a few things. The first one was actually something that Gilad mentioned to me just this morning, which is just sort of a topic for discussion, and that's why I encourage people to move forward so we don't have to shout at each other. Right now, ODP has a set of thread APIs, but we also have the notion that the active entities that are the execution entities within ODP may in fact be processes, not necessarily threads, because the ODP APIs themselves are not implemented as are exposed as shared memory interfaces. They're basically message passing interfaces. So the question is, does it make sense to try to use a more neutral term like task rather than thread, so as not to unduly suggest that you're running in a shared memory environment? Any thoughts or opinions on that? I noticed, is Petri here? No. Well, it won't be much of a discussion if I'm the only one talking. So, well, something to think about. We had some additional buffer management routines, which were again also suggested. There's is Ola here? No, it's not. Ola Lildal. The other Ola is here. There was some question about the naming of one routine where there was a suggestion, and the last time we brought this up, there was still some open debate on that. I thought we could perhaps get in, settle that as to what we really wanted to call this particular routine. And then there were some other questions which came up on Monday relating to packet I/O hybrids and implementation-specific metadata, which I think are worth talking about. And if we have time, you know, we can. If other people have other topics they'd like to discuss, you know, this would be a good place to do so. So the idea behind the segmentation model that we have in buffers is that a packet is or a buffer is an abstraction which may or may not be contiguously addressable to an application that's referencing it, and instead would be accessed on a segment-by-segment basis. And again, Gilad pointed out that in the case of NUMA architectures, since making a segment addressable may involve some behind-the-scenes magic, having an explicit release call would be useful to assist in maintaining coherency. And so the idea is to have this as a bracketing call to the segment addressability routines, basically intended really for NUMA architectures, and with the intent that if you are in a shared memory environment, this particular API would likely just be a no-op, right? So there would be zero performance impact for that.
So is there anywhere that we've got like what a pseudocode or whatever that would show how this might all play together?
Thank you for that excellent setup.
Excellent segue. Oh, well, there you go.
We didn't rehearse this in advance. So if this is again from the buffer design doc. So the idea here is I have a snippet of code which is I just basically want to walk through an entire buffer. And I'm going to do this by segment. So I allocate the. You don't have pointers here, so you'll follow. I basically get the first segment, and then as long as I haven't reached the end of the segments, I get the address of that. I do something with the segment, and then what I've highlighted in yellow here is the new API, where I basically just say, tell the underlying implementation I'm done with this segment, and then go on and get the next one. What I had originally assumed here is that the application is really only dealing with one segment at a time, so that getting the next segment is sort of an implicit release of the previous one. But there's no harm in adding this extra little bit of syntax, especially as I said, this can compile away to nothing for non-NUMA implementations.
So does this actually remove the segment from the list?
No. The intent of that is it's basically the reverse of the what I did. If you look 2 lines up, I have a char star seg pointer is ODP buffer segment adder. So that basically says, give me a pointer that I can use to reference the this segment. Yeah, Gilad?
As the person that suggested this, I just wanted to explain why it's used and therefore the semantics, and then we can talk names, right? But the idea is that if your architecture is one that all the buffer segments are just someplace in memory, and you're just a pointer, so adders just return this pointer. Obviously, you don't need this release. But if your architecture is such that for whatever reason or whatever implementation, the segments data are not accessible in your virtual memory until you do something. You go and install a mapping, like add a TLB entry, or even copy using a DMA engine something from non-addressable memory to a local buffer. You do need that a bit that says, okay, I'm done. You know, I promise not to touch this reference of the buffer anymore, and the address from that point onward doesn't make sense. So we can leave it as address and release, or you can say, you know, map and unmap, get and you know, release or put or whatever. But that is the semantics that I cannot access the pointer until I said that I wanted it. Only then the pointer has sense, and release on the end is the point where I say I promise not to touch this anymore. And as long as I got the mic, one more thing, if it's possible, if nobody feels it's too obstructive, maybe add it to the release or to the getting some sort of flag that I could sort of give a hint. Do you need to copy the changes I made back to domain memory or not? And again, for architecture that where this doesn't do anything, so they don't do anything anyway, they don't care. But it can be a very good way to give a hardware acceleration that use DMA and this kind of stuff an extra hint whether to do a transaction to the memory or not, if you know the program knows to give this hit.
Yeah, that was certainly one of the things you put in the doc as a suggestion, and I wanted to discuss this here with regard to an advice as to whether the you know, to consider the you know, it's a dirty cache line or something that has to be
Yes.
copied back. The concern I have with that is really twofold. One is you know, it obviously if it's advisory, then there's one thing, but if it actually has semantic meaning, that if I forgot to indicate that and I did make changes, would that be a programming error?
Just do it reverse. The default, if you don't pass a flag, is you need to copy all these back, but you can pass the flag that says.
So the optimization would be I assert to you that I have not touched it, I have not changed this.
Yes,
Okay,
it's a one-way optimization. If you don't know, just use you know, don't think about it, just put the line and it will work, you get lower performance. Then, you know, when you want to optimize, then you can go in and say, here I really know that I don't, and you pass the hint, and it works.
Yeah.
Also, by the way, even on architecture that this has no meaning, from a debugging standpoint, it can be extremely useful to just, you know, add a reference counter, print, you know, I've lost this segment, something happened, and, you know, this is like a hook that we can use whenever such information is needed for debug for architecture.
Yeah. Anyone have any comments on this?
Are there implied semantics that an Gilad sort of mentioned this a bit. Are there implied semantics that an implementation may ref count a segment on a segment-by-segment basis? So if that's the case, then the last two lines would probably need to be reversed somehow. I'm just trying to understand the semantics of the segment next, segment release.
Well, the idea behind segment X, I mean, again, this is a snippet from the buffer design doc, which I don't know if I mean I can pull this up. We go through it in more detail if we need to, but the idea is that that buffers are logical constructs which may actually be implemented as segments, which are the contiguously addressable pieces of a buffer, and it's implementation dependent as to what the sizes of those segments are. So different implementations will choose different segment sizes. From an application perspective, all it needs to know is that I'm addressing the buffer one segment at a time. Now, one of the attributes you can have on a buffer pool, which is where buffers come from, is that you want this particular buffer pool to be unsegmented, which basically means that the segments are big enough to hold, you know, the entire entity that you're interested in. But for those where you're allowing the implementation to do segmentation, then there's some mechanism for accessing the individual segment components of a buffer. And there's three different ways of doing it. You can do it by just walking through segments using this segment next. There's accessing it by segment index. So I say I want segment number 1, segment number 2, etc. And then the third one is just doing it by offset. So you're not even talking about segments at all. It's just that from an application standpoint, it says I want to see byte offset X in this buffer. Okay, and the implementation then figures out, oh, that's in segment 3. I'll make sure that segment 3 is addressable to you. And so similarly to segment release, there would also be an offset release. And the intention is that would be used in code sort of like this, where now instead of addressing by segments, I'm basically saying, hey, I'm starting at offset 0 into the buffer. I say, give me the address of offset 0, and it'll return, okay, here's the length, the number of bytes that you have available to you at that point, or I do something, and then release that particular offset, and then go on to the next offset that I'm in the packet.
I think the root of confusion was that it does not release the segment itself, it releases the previously mapped memory. So the segment itself is still perfectly valid and can be used in further APIs. So it's an example actually that was on the board, the seg PTR is not accessible anymore after the release. The seg itself is perfectly fine. It's just still valid. But that's what person was confused.
So I mean, do we have
a
better choice of name to suggest, or that function?
It's not quite the name, but the semantics that the application should assume, right? In the sense, and yeah, I got clarification on that. So the segment itself is valid even after the release.
Right. It's the addressability to the segment that you're releasing.
Right.
Okay.
Yeah. I'm releasing the address, not the segment.
Yeah. Yeah. We're trying to come up with names that are reasonably concise and yet clear by their name what they're intended to do. So. If release was the name that Gilad initially suggested, it seemed fine to me. But if we can come up with a different name which better communicates the intent, that I have no problem with that.
Just thinking aloud, if we have ODP buffer offset map, and then actually have ODP buffer offset on map, maybe actually that would be a bit better, reminding that there are
so would you turn this? Would you change this to buffer offset map?
Right.
And buffer offset unmap. And then presumably here you'd have buffer segment map and buffer segment unmap. Yeah.
It's how you specify.
Right.
Other imply that it sort of exists always, right? When you do actual map on map, that's a constant reminder that it's just transit thing. Actually, you got it, you work with it, then actually kind of you release it, don't touch it anymore.
Right. I think we originally didn't use mapping because that would sort of imply that there was it's some high overhead function where if it's doing TLB entry manipulation possibly or other things, whereas in the case of an SMP implementation you're basically just it's just a pointer, so there's nothing. But, right. Okay. Okay, well, I mean, we can certainly here. Let me just see how that looks. So if we were to change this to app,
Is there any type of naming pattern documented
yes,
that's global?
yes, and that's whoops. So would code like this be clearer? You like it better? Do I have a third? Okay. All right. Well, we'll change these to maps and the same thing for the offset. Make that use map and unmap instead of address and release. If that makes it clearer. I said a well-chosen name is worth a paragraph of comment. So.
As far as the relationship to the packet APIs, I guess from an application standpoint in relationship to the packet APIs, this is not going to bubble up into the packet APIs as well, right? You're basically going to determine that your packet is built out of buffers that need all of this, and your application is going to do all that manipulation.
Yeah, I mean, packets are basically a type of buffer. So
Right, but I mean, we have functions today that say just give me a care pointer to the L2, right?
Right,
so
right.
All of this, I'm trying to visualize how all of this is going to relate to those APIs.
Those APIs are unchanged. So here's the deal. In every implementation that I'm aware of, the first segment of any buffer is sufficient to contain the headers. I mean, in theory, one could have a pathological implementation which uses 8-byte segments, and it would be very cumbersome to deal with. But typically they're on the order of 256 bytes or whatever, which is adequate to cover the segment of the headers.
Right, but if my application, I have to know not to step off the end, right?
Well, yeah, I mean the length, the size of the addressable element is there, but again, unless you're dealing with a very large number of shim headers, that shouldn't be a concern. You had a comment, Bill?
Just one question in this regard. I'm fine with this, that if you ask for the L2 header, it's magical because it's the first segment. That's fine. There's just one pain point. If you're doing it as just for read only, right? Because you want to look at the header, that's fine. If you're actually going to change something via that pointer and expect that to be reflected in the frame, then at least in several platforms, my platform that I'm aware of, that would be problematic without a specific, designation. So the question is, are people okay with saying, okay, if you asked for the L3, header pointer, that's fine, you get it, but don't assume that this is the main copy. Maybe you've got the local copy.
Yeah, I mean that's not intended to be a method of rewriting headers.
Exactly, that's what I was aiming at. How do you rewrite headers, by the way? In ODP.
I was going to say, because I mean we have multiple examples right now that do that.
Oh, really?
This is a very good point, because when you rewrite headers, that has implications on the egress, which relate to hardware calculated checksums or depending on which headers have been touched in the data verification.
Not to mention
That's like a major.
So here's an interesting point, and this is going beyond this particular topic here, but on the case of headers, do we want to be manipulating headers, or do we want to consider the information that's contained in headers to be metadata and access it and manipulate that via accessor functions?
You're saying you can only modify things that...
No, I'm just saying that in terms of stylistic approach, that, you know, and Petri had some, I think you had
At least up until now, I think I expected that all the buffers are in coherent memory, so that I can read and write any byte in the packet in the buffer, and as long as the synchronization is taken care of, I'm sending the packet through queues or things like that, then other cores see the modifications automatically. So I think like network processor case where all the memory is not coherent, that's kind of exception, and we could try to solve that with some design pattern or some like keep that as an exception, I think.
So it's then subject, if the implementation's responsibility to make it coherent if it's not natively so.
So I would expect that everything is coherent, keep it simple, and then if it's not, call some API. So
I agree, it's simpler. I guess it's a larger question of what do you want ODP to do, right? Once you are with a lot of cores, once you go to higher frame and bandwidth rates, these kind of the issues of how do you pound the DDR become the breaking factor. So if we hide our eyes for this, which is fine, basically exclude a lot of platform, which again it's a valid choice, but realize that means that the API, as an API, limits any platform for reaching more than a certain level of performance. Because just saying, oh, I'll just take the pointer right there, there's a hardware that goes and takes this cache line and writes it to memory, and that DDR transaction and calculates ECC, and there's latency involved. And if you do that and don't care about it, that's fine, but it does happen. And so for high performance, even not so high performance, you really want to know that it is happening, not just assume that let the platform do the worst case and always pound on the DDR. So I guess that's a choice that ODP at large need to make between keep it simple, but then it's only simple, mostly software oriented with not sophisticated hour acceleration and limited in gigabits and frame per second, or we're okay for creating an API that can scale up to 800 gigabits per second.
Yeah, that's my point, that majority of our applications and those like larger code bases, those are not like typical network processor type of applications. It's like packet in and lots of computation and logic, lots of code per packet is executed there. So yes, we have some applications that are network processor like or line card type of part of the application, but that's like that's only a small part of the whole code base or the problem space of the whole product. So I wouldn't force all the millions of lines of code into the network processor model just because 1% of the code is network needs that. So I understand your point. Yeah, that's a valid point. But our application is not all the application is 800 gigabits per second rate. So
will API something like buffer offset commit, or like to have two API to release the mapping, one which is like write back your changes and one which is just release resources and don't write back your local memory to the main DDR? Will it work for you, or like all other platforms can have knobs on this?
That was what was suggested in the agreed, but the point was raised that other APIs that also map that other high-level APIs for the packet that says gives me a pointer to L3. People express the notion that they don't want to have that explicit release either way, and I said, okay, we can live with that if that means that becomes read-only. Again, the question is, do we ODP as community needs to take the decision if we're limiting ourselves, or not limiting, but choosing to only implement an API that's good for These kind of application where actual packet processing is a small amount of what we do, which is what I understood you're suggesting. Again, fine. Or it's a data plane oriented application, then we need to have the API to be able to support that.
So question related to the API. If I don't do this at map and I'm running on your platform, actually what would happen? I'm suppose when I will release the buffer, you can go and actually unmap actual segment section. You kind of clean up actual this actual stuff. And frankly, the issue that was brought up by Robbie, we already have huge actual code base, and we're effectively looking how we can retrofit that code base to actually new APIs. And we definitely don't have actually any unmaps because conceptual actually code runs what Petri meant actually completely addressable all the time, all the things, right? So we don't have this magic bring it in, release it back. So, and going back actually to the general requirements, ODP is not the goal to squeeze every juice of bit from everything, right? So if the guy can go and implement still beneficial, but maybe not the best actual option that you can do on particular hardware, but you're getting actual uniformity, still may be actually okay. So I'm saying if you drop actually on map, actually hold this actual thing actually completely, it still may work on your platform, right? That you just will do actual kind of unmap actually yourself late actually for all those things, and you may be just restricted on resources, but ODP implementation will still run, right?
So I had this dialogue with Bill, and the question is, okay, so how do I know when to unmap, when it's safe to unmap? And when I release the buffer, there is. What happens if I want two buffers? How do I mean, it just gets complicated. And I understand that.
One of the assumptions here is that any addressability to a buffer is implicitly released whenever you add that buffer to a queue.
If you cannot trust that the memory model is coherent, then the next question is that in which points I have to synchronize. If I modify the buffer and not send it, it's like if I use some other synchronization method, so like it gets complicated in the application logic. In which points I have to synchronize the memory, because I cannot trust that is this like is it the copy or is this a copy or the master copy of the data and so on. So I think majority of the code just expects that it's coherent, that it's always sync with other cores.
I would agree with that. The model is the application assumes coherent memory.
Yeah, but I think this is needed if you don't have coherent. If the buffer is not in the coherent memory, then you need this. But if you expect that it's at the normal case it is that the buffer is in the coherent memory, then you don't need this call.
Well, so it's coherent, but it may not necessarily. I mean, it's coherent while it's addressable. Okay, but it's not necessarily always addressable.
I mean, again, it's a valid decision the ODP community should make. That's fine. I'm just pointing out, even on x86, right? It's not like this weird machine. If you look at like how packets and stuff are handled in in the Linux kernel, there's kmap, knmap, right? We didn't invent this, and I can assume also I'm not that familiar with the ARM 32 bits. It comes from the restriction of memory space. So again, I'm fine with any choice. I'm just saying if ODP wants to support the big NUMA style things, it's not about coherency, it's about access latencies, right? Yeah, I can go change anything in memory, but that's just not the model that it works in any way on NUMA. You want to bring something locally, work with it, and release it.
So even though like in NUMA systems, it's a matter of configuration. You would put the pool that if you know that this node, this SOC is going to process packets from this pool, then you put that pool into that SOC's memory. Yeah, but you can configure it. You have a classifier. You have multiple pools. You have multiple SOCs connected together. But you don't have to do the stupid configuration that you always access memory of the other SoC. So you can configure it wisely so that your pools and workloads and those are like mostly local.
Again, I think that to argue what can be done, it's not the point. It's a decision the community needs to make what model are we supporting. I can go into the details and explain why what you suggested can work, but it's in a very limited case, right? Because when a frame comes in, it needs to be somewhere in memory for you to decide what to do with it. If later I need to copy it, it's an extra copy in DDR bandwidth. But the point is, I'm perfectly fine if the community as a whole says, you know what, we're not interested to support this, the big guys, multi-core per 5 packet rates. It's fine, but
you're giving us actually false choice actually in this discussion. Actually, it's kind of like it's not actually those alternatives. The question is actually, if you don't have this API, right, and you actually kind of on your implementation, given you cannot actually kind of like perform as best actually as you potentially actually could, but you still can perform much better than actually kind of without actually your accelerator. That's going back to my point. When the buffer is released, you kind of go and actually release all those actual memory and unmap it, and you don't need actually this unmap thing, and you don't have this inconsistency actually what Robbie brought up actually with layer 2, layer 3, and all the stuff that you kind of like unmap. Clearly alone is not sufficient because you need to start building all those things, and then the question, if I ask you actually once layer 2, then I ask you layer 3, how many unmaps actually I need to do, and so on and so on. So my question is, why your implementation cannot keep it actually addressable for the lifetime of the whole buffer, segmented buffer? When the buffer is actually kind of released, it will be kind of released. So the only difference that makes is its number of buffers and number capacity of the flight would be actually reduced, but it still be okay. Actually, it's just it will not be performed best what you could do, but it still performs ODP wise.
The main difference is time when you release it. Like anyway, the idea of ODP is that you work on the packet and then push it to the next queue, and when you push it, you can release it. So this is like short time. So the only thing that you have to assume that the packet was modified each time.
Yeah, that's again the point I was trying to make. And the idea of ODP, that's what I understood, is to give some sort of the same abstraction interface, so you can use hardware acceleration where it makes sense, right, without having to think of each time of each platform to modify it to some degree, right. For me, this is a kind of hardware, the kind of if we define the VA like this, I can use specific hardware acceleration to do something. If we're not, we can't. Which is again, it's fine. Do you want to support implementation which do bring something in, work on it locally, and shoot something out? If the question is no, we're not interested, then again, it's okay. All I'm stating is that the reason that this kind of model exists is because in a big numerous systems, localities is everything, right? The idea that, yeah, I'll just bring everything in, I'll latent change it, and then write everything out will work. But there's a reason why you would want to bring something in and just write out that the DDR bandwidth, that the kind of is a huge effect on performance. So all I'm asking is, do we want in the API the places we can enable now or even later on whatever platform to know what we need to sync or not? The DDR performance is what affects performance in data processing to some degree. Without it, we just don't know. Forget my specific platform.
Well, I think that this is an area that clearly is going to evolve as we gain more operational experience with using ODP in different environments.
I would like to see, I can envision how you could end up with a suite of layered APIs that, to Petri's point, at the highest layer, I want at least somewhat contiguous view and a read-writable view of a packet. Yeah. And that if I want to code to that layer, I can get the functionality. Mm-hmm. If I want to take advantage of this kind of performance enhancement, that there is a ODP exposed layer that probably most likely that higher layer is built on, but it's exposed such that now I can write my application to take advantage of it if I want to.
Mm-hmm.
But for 1.0, that seems like a lot to try to, you know.
Yeah, I think you're right. That's really beyond the scope.
No, not one at all, just.
A lot of is, you know, what is the scale and breadth of application that we're looking at?
Exactly.
To your point, you know, I think the behavior and optimization point, I don't care how generic you try to make it, is absolutely different when you have 1 core and when you have 1,000 cores, right? And so to your point, the decisions and trade-offs that you make with 1 or 2 cores versus 1,000, I think your points are perfectly valid. And I think that's one of the struggles that we've got to talk about is can we come up with potentially multiple APIs or a layered approach to be able to optimize across as broad a range as possible? Because it's different points, period.
That's fine, as long as the application writer comes and he has a choice. Here's the simple API, use that, it'll work fine on this. You want high performance, is the lower level API, you choose, that's perfectly fine. And it's fine for 1.0 to just do the higher level. Everything is okay. I just wanted to understand what's the decision as a community. What are we targeting? Okay, cool.
So, but in this particular case, I think actually you don't even need two variants of API, right? So let's go back to the question: what if application didn't do this actual call? So yeah, sure, you should what it means actually for your actual stuff. You should keep it actually addressable. But the only point actually where you can get rid of it is the point actually where you in queue or actually where you release actually as a buffer. But my second point is actually with the current actual map and unmap, API is not complete with respect of the point what the Robbie brought up. Actually, what about actually if I'm getting actually kind of specific actually headers or the semantics, and I'm kind of it's need more details because, as I said, if I take a layer 2, then I take layer 3. Should I call actually twice unmap? What does it actually really mean for all those actually APIs? So this one is actually just start for your actual situation, but if you want to somebody utilize, you need to clarify actually for all those APIs actually as well.
Okay, I'm perfectly willing to do that, but what I'm hearing is that if I want to do that, you would like to see a suggestion that has a higher level, let's say blind eyes API that assume everything is addressable, do the magic even if it's used performance it, but you would be okay if there exists a lower level API and let the application developer choose that. That works, but again, it means taking the assumption that yes, you could run this on a platform where things are not coherent, and it should be.
Yeah,
okay.
I'm a little new to this, as this discussion is talking about a specific API, but the problem that we have in our company is we have a lot of applications that have been designed to run on a single core or x86, and some of these have run on Ultra Spark or PowerPC, and they have made the assumption of single threaded performance in a read-write model. But most MPUs, to operate efficiently, have to manage this packet in a non-coherent space. And they have choices; they can move these things around or not. But typically, they will try to manage to do as much work as they can, manage buffers such as these ODP buffers in a non-coherent space, and then release it, right? And you have the choice whether, I guess, you guys consider what do you call it, like committing a change to make it coherent, or just releasing the buffer for the purpose of recycling that back into the free pool. But if our motivation, and definitely the motivation in our company, is to allow this capability to run these applications that have been, assuming x86, to be accelerated for, tens cores, 50 cores, thousands of cores, then I think we have to make the assumption for a lot of these applications to accelerate, it will have to run in non-coherent space.
Okay, that works for me.
Well, I had wanted this to be design topics, so I'd like to move on if we can, because we only have another 7 minutes. But this is all good discussion. There was also a suggestion that we have an existing buffer duplicate routine, and the question is whether we also wanted to have a buffer clone routine. And the difference between them is that buffer duplicate basically has a potentially copy on write lazy reference to the underlying buffer, whereas clone is a guaranteed, physical copy of that.
No, I actually always thought it's the other way around, but okay, just from the name of the syntax, but whatever.
Don't care. Okay. One versus the other. Since Ola is here, this question of the name of this one routine is whether it's buffer segment index or buffer segment by index. I think the last time we talked about this, that we had a mixed view of that. I don't know if there's a consensus. And right now it's buffer segment by index, because that was the last suggestion that was made.
I think since we don't have this little get in fix for functions that will return something without modifying their objects. If it was still named that it was originally buffer segment index, then I would assume it actually returns an index, which is not.
Okay.
That's why by is needed.
Sold. So the couple things that came up on Monday, and I really just wanted to raise this for additional discussions because I know Stuart wasn't here on Monday, and he's currently looking at Packet.io. The very legitimate point was brought up that SOCs can contain hybrid I/O. For instance, a native I/O, NICs, USBs, all basically visible to the application. So we need to define how hybrid I/O interfaces map to the ODP Packet I/O abstraction in a portable manner. Since an ODP Packet IoT is an abstraction for an I/O channel, really should present the same semantics, and the only difference should be the system metadata associated with that interface. So, for instance, speed, capabilities, other types of attributes. Stuart, had you been thinking along those lines in your thinking on this? And if not, that's okay.
Also, I guess that you just pass a named reference to the device type to the Packet.io. So you get the handle back, and the handle is the same regardless of the applying implementation.
How is different from 1 gig and 10 gig? Not supported by one implementation. I don't see actually kind of anything new here. So you have a list of interfaces that particular implementation actually can support. If it can support only actually the one of accelerated on 8 property implementation, other implementation can support that number of interfaces and actually UTP and Ethernet actually 1000. So, or they may actually just come back and say, you know what, my implementation currently supports only gig interfaces, which is accelerated, and never support the RAM gig. Nothing different. So it seems, I'm kind of like, I think actually it came up actually this non-existing problem.
Okay. Good. And the last thing that I think Barry from Telera brought this up in conversation. I don't see him here. I think he had to leave yesterday. But the question of implementation-specific system metadata, and the idea is that certain implementations we're going to define a set of metadata, system metadata associated with any given object, but given implementations may have additional information which potentially is of interest to an application. And we understand that this is not necessarily portable. However, it should be available to those apps that want to access it in a consistent manner across implementation. So the question is, how do we encompass that? And the example that he gave was that on their chip, they will timestamp a packet at the pins on its arrival. Now, obviously, that is potentially fairly useful information for high precision timing and other type of performance data. Obviously, it's not something that we're going to invent for if you're talking to a USB device, okay, through an I/O. So it may not be the sort of information that would be part of the standard ODP API as, this is metadata that every packet is assumed to happen. But a given packet I/O may have additional capabilities, and the question is, how does it prevent those additional pieces of metadata in a consistent manner? And so thinking about this, it seems to me there's three ways that we could approach this. One is to say just use implementation-specific ODP accessor functions. So I may have the standard ODP accessor, which for a particular object would return data which is not available for other ones. But then that's confusing as to, is it really intended to be common, or is it explicitly an extension? The other possibility is we already have this notion of ODP helper functions. So could we define a similar sort of helper function for metadata which allows for implementation-specific extensions? And then, of course, the question comes is how does that operate from a header file standpoint in terms of integration? And the third point would be, since we can access the SDKs, the vendor SDK from within the ODP application, should we just basically say, well, if you want to provide a extension, just have your SDK accept the ODP object type and return it that way? And I just didn't know if we had any thoughts or views on which approach makes sense.
I think the last one.
The last one.
Yeah.
It just if you look at this actually from application-centric point of view, so what my code will have if def, I don't know, Marvel SDK, right?
Mm-hmm.
And then kind of okay. So if I use actually different prefixes there, or kind of like do actually the call, this is not portable code. That's it. I have if def Marvel SDK. So frankly, this group shouldn't care actually kind of what do we have actually under this actually piece. That's kind of my position on that.
Well, that's certainly very clean, and since the vendor presumably is owning the ODP implementation for that platform, they know what the representation of the ODP abstract types is for that. I know we've got some Tylera folks here. Does that seem reasonable to you as an approach for this? I know Barry's not here, so he may not have talked to you about this.
No, you can add a shim right there. Just add another abstraction layer, right? That's all we do. Just one question in this regard. If it's some property which is unique to a certain platform and none else, I don't care, right? It's not ODP territory as far as I'm concerned. But timestamp, actually, I don't think that is a good example, because I can imagine a lot of platforms that can put a timestamp in, at least on some interfaces, and then there's a lot of platforms that not, or at least not all interfaces. So how do we handle these kind of things which they're not the same across all the board, but they're still useful in many applications when you use them? I mean, you will still have to do not an if-def for this vendor or that vendor, but you would have a if-def. Do you have this feature or not? So.
That's completely different situation, right? It's not vendor specific. We have a similar situation with ODP crypto, right? We just said actually, okay, here's the enumeration protocols. Not all platforms will support the same actual set of protocols. We're not requiring actually them to support actually all the protocols, but there is actually generic API to access those things. It may be there, not may be there, and the dynamic way to discover it. But that's constitute actually ODP API. If you want to push actually kind of certain actual metadata attributes on that level, maybe there, maybe not. It's still ODP API. It's not, I think.
All right. Well, I don't think we have it at times in our, as is the tradition for the ODP design calls, we have run over slightly. So, which means there's always interest in these things. So thank you very much, and let's get something to eat.